Hello, the purpose of today's video is to present the final exam for EET 423 for the spring of the 2024 semester. What we're going to be doing today, or this morning, or today, whatever time you're looking at it, is just giving you a little bit of background on how to perform the exam. The exam is take home, so you have open book, open note. You cannot use a colleague or a friend. It has to be your own work. So just some key things here. The real purpose of a lot of what we've been doing this semester is to get you to understand how to be successful to work in industry. So as a result, the expectations are for assignments, it should be consistent with what you would turn into your supervisor or to a client. So make sure your responses are typed. I'm not expecting to do CAD logic diagrams, but if you are going to use logic diagrams, make sure they're very well drawn out and clear. There are applications that can make it really easy. Some of you have familiarity with AutoCAD and you can use that. Also, Visio is a good application to make that work. So you could certainly try that. The next thing is make sure any figures that you need are clear. So if you have references, that type of stuff, you definitely want to go ahead and make sure your references are, your figures are included in your submission. Any references, including any date codes, if you use the Schweitzer manuals, they use not revision history, but they use date codes for when the document was issued. So specifying that would be useful. If you did have to use any electronic files, then please use those or submit those. And Quickset, we all know about Accelerated Quickset. Test Universe is a software application where you can do some testing. If you have to do things in Excel, make sure you provide those. But what I'm looking for with those submissions is just to make sure that the information is consistent. I'm not looking to look through your Excel file to see if you've entered equations correctly or done calculations correctly. You need to do that work on a separate piece of paper so that I can follow that. And the reason why that needs to be done is because sometimes it's difficult to figure out what people are doing in Excel. You have to go cell by cell, and it can make it really cumbersome. So doing your calculations or a sample calculation of how you'd implement something by hand is much more useful, and then you can do the calculations and plots in Excel. So giving enough information so that people know what exactly you're doing. And then finally, if you are using LEDs or push buttons on the front panels of the relays, you certainly want to go ahead and include a screenshot of whatever that is, and then you can append, and it's pretty easy to do that in Word, you can append what those LEDs or push buttons are indicative of. All right, so first question, we have a 451 relay, and we're going to be using all SCL relays. If you want to use a different relay manufacturer, that's fine, but just keep in mind, you'll have to give me enough information. I'm very familiar with GE relays, the UR series relays, but if you use a more commonly known relay like a MyCom or Beckwith or something like that, then I don't have as much familiarity, so I would need additional information from you. But if you have a 451 relay, you've got a CT and a PT as shown. I've given you some impedances, and these are in ohms. These are primary impedance values. So this is on the high side or the equivalent high side of the system. So they're actually at the system voltages. These are the impedances. And you have the line length. What I want to do is I want to be able to detect where a fault has occurred on a line based on this information. So you can use this capability in the relay to help give you a little bit of information as to where to troubleshoot, where the fault might physically be. So that's question number one. Number two, we have operators who want to enable a DNR, do not reclose function. And a do not reclose function is one where you're basically trying to prevent the breaker from automatically being reclosed. As we've talked about this semester extensively, a lot of what we're trying to do with the system is maintain very high reliability. And one of the ways we do that is, if it's possible, we will reclose in a circuit that has a transient or incipient fault. And there are some cases, maybe perhaps, where you do not want to reclose. And so this is going to prevent that function from occurring, the reclose function from occurring automatically, and it's going to prevent that. So this is something that should be configured where you have to enable it, and then you have to disable it by doing something manual. Okay, so that's going to be done via push button. You're going to enable it and disable it, and it can last, the DNR function can last for months if necessary, even years or something like that. So it's something that should be there for as long as I want it. The next question is, You've got an SEL 387 relay, which we know the 87 is a differential relay. It's a 300 series relay. With the 3, I would like to have you develop a detailed test, isolation, and restoration plan. So you're trying to go ahead and do testing inside the relay. And I don't need you to write the specific test. I just want you to write me an isolation plan and a restoration plan, which will helpfully prevent any external trips from occurring. So you're going to be taking the device and running it with different voltages and currents, making sure that all the trip functions and logic are working as intended. And what you need to do is make sure that all these things can be tested in the relay without actually causing a definite trip. And then also, I want you to determine 3 test points for using an overcurrent element in the 387. As you know, it's a multi-function relay, and you can have different operating curves implemented for overcurrent. So you have a time dial, a pickup, and you have a curve type. And then I will show you these, but I will also provide this. This is one side of the elementary. You can see that you have the 387 relay in here. You can see the part number there. And then you can see all the I/O with some test switches. This is the first sheet. And here is the second sheet. And there's also some test switches here that you may or may not necessarily need to know. That is the biggest point problem on this. So make sure you spend some serious time making sure you have a good isolation restoration plan. And then the final problem is you have they've updated their transmission lines, so they've decreased their primary own impedance by 10%. So they've gone with a larger conductor, or they've gone with another parallel conductor to go ahead and do that. And so the client is asking you to reconsider if the existence distance settings, so the settings before the line was upgraded, are going to be sufficient or not. And do you tell them that the existing setting is acceptable, or do you tell them something different? And you can't just say yes or no. You have to tell them the reason why I'm recommending it is blah, 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 or the reason why I'm not recommending it is blah, blah, blah. Okay, so you can see the due date. It's due on May 1st at 4 p.m. So you should have a pretty good amount of time to do that. So thank you very much. I hope you enjoyed this brief video, and I look forward to seeing your submissions. Take care, everyone.